So, when you kind of start in that small win approach, again, back to the lighthouse, those transformations tend to happen 25 to 50% faster when you kind of start small and scaling that. And that comes from remaining focused on what you're trying to prove and accepting that you're going to do this in an iterative way. Because I guess we've heard this phrase yet, start small, scale fast, or fail fast. And I think that's really important because resources are always going to be limited. So if it's not going to work, you don't want to spend 6 months trying to prove something and find it doesn't work then. You want to prove it within 2 or 3 months that it's going to work or not. Have a plan to scale it or a plan to say, look, let's be honest with ourselves, this isn't working.
Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to the latest episode of the Trend Detection Podcast. I'm really pleased to be joined once again by Nick Leeder, a familiar face to the podcast now. How are you, Nick?
All good. Trying to remain cool on this really hot summery day in the UK.
It is. I don't know. I mean, most people will be listening to this actually, but yeah, if you happen to see us, we might slowly melt through this podcast as we get through. But we'll try and survive the best we can. But today we're talking about a not unfamiliar topic, AI. But hopefully we're going to have a new sort of angle on it because we're talking about AI beyond the hype, which I think is a very challenging topic actually, Nick, because it's impossible not to hype AI, I think, at the moment. But yeah, so I guess let's dive straight in really around this topic. I mean, why did you came to me with this topic as a suggestion. What sort of got that sort of thinking in your head, Nick?
Yeah, well, to be honest, when you say hype, I mean, there's hype and then there's hype. And I think where we are right now is that everybody, vendors, my clients in the manufacturing industry, everybody needs to, or they feel at least, they need to be seen to be doing something with AI. And, even some of the execs I've been speaking with, I mean, I was speaking with a CTO of a UK PLC company, and he's sitting in board meetings and they're talking about what are the AI projects that they need to do. Not what are the problems we need to solve and how AI can help us solve those problems or change the customer experience or provide new functionality that hasn't existed or insights. So the thing that's frustrating, I guess, for me is that AI, however powerful it is, I don't think we've yet really understood the true value and potential, and we're probably spinning it in the wrong way.
And that's interesting. I mean, you've sort of hit the nail on the head there in terms of, understanding the value and the value. Do you think, and that must be an issue where people hear about AI and needing to do AI projects. Is it sort of going too quickly ahead with things without actually thinking about, how can we apply this to, business challenges?
Yeah, there's a phrase actually I'm hearing more and more these days, or at least I'm saying it more and more, which is the capability of these tools is outstripping our ability to take the value from it. So, what I mean by that is, I think that just because a tool can do something doesn't mean we necessarily have to use it. And there are so many clever things, simple things we can do in our operations, in our facilities, that take us a step forward, that AI as a second or maybe third step could be incredibly powerful or incredibly valuable. But once we've established perhaps core data that is trusted, that is contextualized in the right way, that you can train off effectively, I think those things, that just having that foundation actually takes you a massive step forward. So we're jumping the technology. So technology essentially is outstripping our ability to consume it. Sorry, there's a little bit of background noise perhaps going on, but it's outstripping our ability to consume it. And therefore we are now we're almost kind of being driven by the technology pace rather than our pace to both capitalize on it, but also, let's face it, we've been living in this world of digital transformation for. If you can't see this, but I'm doing air quotes. Yeah, digital transformation. We've been living in it for, well, at least I've been doing it since the year 2000. 25 years into this realm. We've all got a little bit of change fatigue, and then getting pushed now to do the next thing, because the technology can do it. Actually, we've got to get back to, right, how is this going to improve the quality of my product, the reliability of my machines? How is this increasing the throughput without increasing my capacity? How can I avoid the next capital expenditure? Those things. How can it's very topical from a UK point of view. How can I optimize machines' performance to use less energy to produce the same output? Let's focus on those core problems and then see how the technology supports us rather than the other way around.
And you mentioned some of those use cases, so around energy optimization, predictive maintenance, and things like that. I mean, do these use cases often spring to mind for manufacturers, or is it something usually that needs to be, it's not there until it's sort of in front of their face, kind of thing? I'm just wondering whether it's like an obvious thing.
It kind of is, and it kind of isn't. As I could say, if you're a manufacturer that goes to trade shows, I mean, I guess most companies, if they have in the UK, if they've been in the UK, the big show is at the beginning of June at the NEC with the Digital Manufacturing Week. And you could not move for AI stands. Yeah. Oh, we do AI this. We kind of have AI-enabled tissue dispensers for your toilets, all this sort of stuff. You can track the paper usage from it. It's gone mad. It has gone mad, and it's like there are some very, very important things, I think, that are best suited, I guess, to AI applications. So, we talk about predictive maintenance. Predictive maintenance, as long as you can get constant signals from your sensors, so vibrational sensors, thermal sensors, oil quality, whatever you need, link that back to what you were producing at that time, because there are variables there. And that's the important thing, is understanding and building the correct variables into these models. Then what we've proven, and then what companies have proven over time, is that you can build gradually more models that have higher degrees of confidence to predict potential failures. Now, the word predict is really, really key here, because it's not prescriptive, it's a prediction. So you still need people to, first of all, go in, look at the data, interpret that data to understand, yes, okay, I'm looking at these various signals, perhaps my peak acceleration's gone up. I've done some analysis and looked at the spectral, at the FFTs, and going, okay, yeah, I can see that there's probably a wear on the inner raceway or shaft misalignment, and then use that data to go and verify, and then take corrective action, which is better than waiting for something to break, than basically companies do today. But we're not yet in that full prescriptive view. And I think there's actually a confusion here, where people think also for AI, I think there's a vendor's role. So apologies to everybody from Siemens listening here. But I think there's also an important role for the vendor. So let's get back to the predictive maintenance piece. I mentioned FFTs. I've mentioned, looking and analyzing the data here. That requires a certain level of competence and skills and training. Whereas if we use AI correctly, we can use that knowledge, we can embed that knowledge into the tool, and actually then produce better insights for people to take action without needing that detailed information. Isn't it better to say, hey guys, this machine is going to potentially fail because the shafts are misaligned, or you need to go and check the lubrication on the machine, and just have it as a statement like that, rather than, hey, there's a warning on your RMS or something else like that, you've got to go off and do something. So we need to take the world of complexity. And I've had a recent report or recent blog written and published by the World Economic Forum on this, which is, do we have a skills crisis or do we have a usability crisis? And I think this is where AI could put massive benefit, is to simplify the complexity of all this data to simple actions and information that people can understand, irrespective of whether you're a manager, whether you're a line technician, or whether you're a detail VA2 in the maintenance team.
I guess there's another. I completely get the points you're making, but I guess in order to take action from AI insights, there has to be a high level degree of trust in AI as well. Because there's one thing saying AI is everywhere and we must use AI, but that human instinct to actually trust what the AI is saying is crucial as well, right? To the adoption of these tools.
Yeah, and it occurs over time. So, I think it's good, by the way, to be skeptical, to ask for the tools to prove themselves to be right. But actually, particularly with that usability question answered, I've seen real success stories happen where people, operators get and use the tool. The barrier to entry is lower. They actually go and find out, yes, the tool was right, or sometimes the tool was almost right. I mean, I've got examples of where we think there's a bearing getting loose on a fan. And when we actually look at the fan, what's happened is the fan's in balance because of some debris on the fan blades, but it gave the same signal, as a kind of vibrational signal, as you would do with a warm bearing. So, I think there's trust, and I think that you need to understand the limitations of these things as well. And as you can only do that through experience. That's not saying I'm not going to use it because I don't trust it. It means that I have to take everything with a degree of salt, a pinch of salt, until it's proven and repeatedly proven to give me the right information. And I think that's my gripe a little bit from these trade shows, because you go around, you speak to the vendors touting their latest AI solution, and they don't necessarily have the process knowledge, the detailed process knowledge, to actually explain really how it works, as opposed to, well, we have models to do this. There's a big discrepancy between technology capability and practical application.
But I think it comes back to another word, which I know you use quite regularly, Nick, is about buzzwords as well. So if you talk about algorithms and things like that, I guess people think, or some vendors are guilty of thinking that impresses people, right? If I say, we've got these algorithms, people are like, oh, brilliant. That's what, ding, that's what we need. That's what we need. Is that kind of thing as well, right? That's playing into it.
Yeah, I mean, obviously, if you've got algorithms, there's creams for that. We can solve problems, but in reality, I mean, something like AI, if we kind of boil it down, it isn't a thing. It isn't a product, yeah? It's a capability that you're going to use and develop. And it's about turning data into a way that you can make better decisions. So again, let's strip these buzzwords back to actually what it's actually doing for you. It's algorithm. I mean, who cares about an algorithm? It's about helping you use the data you've got to make better decisions, yeah? It's about augmenting the team and providing, what AI is brilliant at doing is spotting patterns of things, and often patterns with disparate pieces of information. Is it a combination of the machine running speed, the humidity or the temperature in the factory at the time, and what you're actually producing? And those are quite disparate bits of information, but it can connect those things together and predict outcomes, because it starts seeing patterns of failure or issues that occur in specific situations. I think when you think about an approach, which is, can you sense it? Can you decide what you need to do? And then can you take action from it? Tools like AI kind of bring the horsepower to do this faster, where traditionally you'd have, imagine the amount of Excel spreadsheets you would have had to gone through that previous scenario to try and do that. You can speed it up, you can do it more accurately, and you can bring many more variables in that a human traditionally couldn't analyze effectively. So I think when we talk about words like algorithm, let's just distill it down into those simple things that are really relatable to the operating environment of your customers and the people listening to this podcast.
Yeah, no, absolutely, absolutely. And okay, another thing sort of stands out to me as well, because you mentioned, the smart factory event where there's AI everywhere, and I had a similar experience at the same event, not jumping on this event in particular, but around predictive maintenance as well, where predictive maintenance was on everything, like everywhere as well. So which sort of leads me to think, when people are trying to select tools to use, where do they even begin to start when everything's AI, everything's got algorithms, everything? What's the key criteria that people should focus on?
Yeah.
Where do they start?
It's like that kid in the sweet shop moment, isn't it? You walk in and go, "Wow, which one do I want?" So, like a kid would do in a sweet shop, the first thing is decide what sort of sweet you're really after, and then let me translate that into more meaningful terms. Yeah, what's the problem you're trying to solve? Is it about energy use? Is it about quality? Is it about maintenance and unplanned downtime or availability? Yeah. What's the biggest problem you're trying to solve? Understand what good would look like. And then if you've got those two things, then I think you can start narrowing down, because you've got a real focus on an outcome, not a piece of tech. And therefore not all the tech is going to help. Do you want that sweet to be sweet? Do you want it to be a gel kind of base thing? Do you want it to be a sour? Those are your problem kind of comparables, and therefore you're narrowing down the sweets in the sweet shop. And then I think there's other questions you need to think about, like how interoperable are these tools? Can it talk to your systems you have? You might have an MES system, a SCADA, an ERP system. Can it connect to those things really easily? Because you're going to need that data to feed these sort of AI-based tools with more contextual data. Do you need a PhD in data science to use it? Or is this kind of a low-code, no-code type deployment? Yeah. That's another kind of criteria. I remember going to an event and then going, we need more. The problem with manufacturing is we can't attract enough data scientists because the financial services sector is taking them all. And I'm going, hold on, this is wrong. We need AI to be used and data science to be used by everybody. You don't need that. We shouldn't need those sort of skills. The final question is, what's the ROI? Is the problem big enough and worth it to solve? If you deploy this, will the ROI be 6 months, 12 months, or 18 months? If you get if you get a 6-month ROI on this, you've got a big problem that can be solved with a very rapid return. That helps your case to get the funding to actually launch these initiatives as well.
And I wonder with AI as well, whether it also comes with expectations of success, because everyone knows how amazingly productive AI makes everyone. But does that also create an issue sometimes where you expect instant results, or otherwise, oh no, that obviously doesn't work? And there's a bit of patience required, right? Depends on the technology we're talking about, of course. But
there is, but I guess I don't think there's ever been instant payback on anything. I've seen some phenomenal paybacks, or at least phenomenal results with some of these tools. Going just simply measuring stuff, you start to see stuff you didn't know existed. So, for example, I worked with a customer that the HVAC system was working at 3 a.m. in the morning when the factory was shut. It's costing them money. That's not AI, by the way. That's just simple. Well, what's that system turning on at that time in the morning? But I think the other problem is when we start initiating these projects, we make the projects also too big. So, are we trying to eat the elephant in one go, or do you just take bites to prove? And starting with something smaller with very clear metrics that you can demonstrate, whether that's like reduced and unplanned downtime, yield, or energy. Yeah, run experiments as well, so that in every 90 days you're kind of moving it forward. You're capturing the benefit. You're able to share the story of what you've done and the results that you've seen. That builds confidence and buy-in within the organization. And by solving one problem at a time and gradually building, this is something also really important for AI, yeah, is gradually building up the training data and showing that it's actually working and correlating correctly. Building that momentum, one problem at a time, perhaps one per quarter. That, I think, is the big difference here. So it's not the big transformation that is going to take, the classic world of ERP, 18 to 24 months at least. It never works first time round. Start smaller, prove it, and gradually build it. But I think it's important. We talk about a little bit about, I mentioned eating the elephant. You need to at least know what your roadmap is and where you're going to go with it. Because if you only have a small project to prove, that project could well prove, but may well never scale, because you don't know how can you apply this to more facilities or different lines within your factory or different machines? Is it scalable that way? Or where do you build from the next capability on it? So it's important to have a view of what the elephant looks like and the steps to get you there. But you don't start trying to deliver it all in one go. You take the first steps, you prove it, and you grow it.
So maybe it's because the title of this episode is around sort of practical strategy. So how practically can companies measure these small wins in order to enable the effective goal of scaling it further? Obviously, if there's return on investment, it wants to be scaled everywhere. Want to see return on investment throughout an organisation, but how can companies sort of think about that in reality?
So I guess the first conversation is this project we're going to run. Let's say you've got an extrusion machine and you've got 10 extrusion machines in your factory, or 10 presses or whatever, yeah. And start with one and say, right, we're going to improve the reliability of this extruder. And we're going to do this because we're going to use condition-based monitoring or predictive maintenance, evolving from that. And I'll tell you what, and this is the CFO conversation or your line manager. To do all 10 is going to cost 100,000 or something. What I want is 5,000 to start off with, because we need to be prepared to make that investment, but we've got to prove it. So first of all, you've lowered the financial barrier to entry in that conversation, and then start by sensorizing it, getting the data, and understanding what's where you are today. So I think it's also really important to try and baseline the performance, because if you can baseline the performance, right, over the past 6 months, we've had 5 failures on this machine. Each has taken us 4 hours on average to fix. We had one major failure that took the machine down for 2 days. That meant we had this much lost production. Okay, the cause of the failure were these things, and we believe that using condition-based monitoring or predictive maintenance, we can detect these failures earlier, schedule the maintenance in, and avoid the failure. Now, that's always a tricky one for a business case, yeah, because the avoidance question, this is what AI is really good at, is avoiding things often, is like an insurance policy. But it's a very valuable insurance policy. So I guess the thing there is have some very, very clear and meaningful metrics that everybody would understand. And please think of those metrics in 2 ways. The operational KPI, the percentage improvements that you see at an ops level, yeah, that sit in your dashboard, but also translate those into a financial measure that the CFO would understand. And if you can connect those two operational metrics to financial metrics, when you prove that you are improving your KPIs, you can also then directly correlate the financial improvement and benefits of the business. And that will, if you can prove it in that kind of 90-day window I talked about, with a relatively low level of investment, you can say, right, we've proven this. Why don't we start scaling this across the rest of the machines? Maybe not go to all 10, but maybe go to another 2. So we've got 3, and maybe we run this for another 3 months and we'll see that correlation again. And if you see that correlation again, well, then we're ready to invest. So you're scaling, you're proving at each stage, and you've got something that's really meaningful for your KPIs. And just use as much stuff off the shelf. The other habit I see is, particularly when people start playing with these tools, you get a little cottage industry spinning up on the side. So actually take stuff that's as much off the shelf, as easy to integrate to, and get that data flowing and start training that data and try and avoid that cottage industry, because I think you'll see results faster. And particularly if you look at long-term results, you don't have to do all that lifting and then maintenance of it afterwards as well.
And you did mention that before, because when you talk about metrics and return on investment, I guess another great, maybe a great way to pitch it is you've got all these existing systems, right, with data, that may be underutilized, but maybe you can use AI to add a layer on top and start getting more value from that data that's locked in there. I know you did talk about that before, but I thought that linked nicely in terms of that return on investment conversation.
Yeah.
KPIs. Yeah.
I mean, every time I hear about it, I keep forgetting the stat because it's a phenomenal stat. But let's just say manufacturing produces the most amount of data almost out of any industry. I guess banking might be the only other one that's up there, banking and retail, in the amount of data it produces. But the question is it good data? So, we don't worry about the amount of data, but the systems are within your business where the data resides, and AI is not going to replace them. AI is going to use that information to enhance what you do and the decisions that you make. But it's important to pull that data in from, for example, your manufacturing execution system or your MES system, looking at the SCADA, or reporting that information back perhaps into ERP. So a lot of the vendors now have got AI plugins as well, which makes the complexity perhaps at times a bit confusing again. But can you pull that data in? Can you make better decisions using AI from that? You undoubtedly will have production-related data in your MES system. You're going to have machine-related data out your SCADA system. You're going to have additional sensors that you want to deploy to get more specific data points around that thing. And it's there has to be some level of kind of context that you apply it to, whether it's the asset itself, the product. I mean, energy. One of the major SKUs that KPIs that a lot of companies are trying to get to is the kilowatt hour per SKU produced, or the CO2 equivalent per SKU produced. There's reporting requirements from that. So pull that data in, start using that. Integration is often a major barrier to it. So there is a technical lift that's required, that requires support from your IT teams. It requires support from your OT teams. But if you get that integrated correctly and you pull that data together, then that's actually probably the biggest accelerator that you're going to get for your AI projects. So one of the things is I often look at the World Economic Forum lighthouse projects, and lighthouses have tried. One of the things we see quite regularly with the lighthouses is I'm not sure this is a real word, but assetized their solutions. So they're almost like modular pieces and toolkits that they have. And that starts ensuring the interoperability and accelerates the deployment that they have. So that assicization, it's not very easy to say, and probably, again, not a real word, but has a real kind of acceleration component to what you're trying to do.
And if we think of these projects as well, so maybe there's sometimes a misconception or an overthought process about how much time, resources, data, budgets are required to actually get these projects off the ground. But I guess, what's your view on that, Nick? And is it possible to launch something, which can deliver a great return on investment without huge resources, whatever that might be?
Yeah, I mean, I think if we go back to what I talked about in the beginning, there are factors that influence that. The scale of your aspiration drives the budget, drives that, the cost, and the resource requirements. So starting with relatively smaller things that you can prove but have a disproportionate impact to the way you're performing, that's a way of limiting it. And another factor, and I've talked about that already, is the usability of the tool. The skills that you need. If you need data scientists, your OT team and your IT team to get this stuff up and running, there's a lot of external pulls that need to happen and collaboration that needs to happen to make these things a reality in your business. So can you just connect to a machine relatively simply, use some retrofitting sensors that are either wired or running off Bluetooth or LoRaWAN or something, connect it to a gateway and pull the data that way, that actually removes some of those technology barriers which pull that resource position in. So when you kind of start in that small win approach, again, back to the lighthouse, these transformations tend to happen 25 to 50% faster when you kind of start small and scaling that. And that comes from remaining focused in what you're trying to prove and accepting that you're going to do this in an iterative way. Because I guess we've heard this phrase yet, start small, scale fast, or fail fast. And I think that's really important because resources are always going to be limited. So if it's not going to work, you don't want to spend 6 months trying to prove something and find it doesn't work then. You want to prove it within 2 or 3 months that it's going to work or not. Have a plan to scale it or a plan to say, look, let's be honest with ourselves, this isn't working.
Yeah, and I think that's a key part of it as well, because I think, it's just an interesting point about the honesty part, because there is sometimes when time's been invested or resources have been invested, it's hard to let projects go. But I guess that means you can allocate resources to another project, which is maybe a better fit for your business, right?
Have a higher probability of success. I mean, let's face it, the world we're in right now, with all the uncertainties, getting any funding, particularly large-scale funding, it is difficult. And you've got to have almost that bulletproof business case to the CFO to get anything large off the ground. So you start that smaller position. But also, I don't know, I've come from running these programs in industry for a long time. If I see a report that is all green, I immediately become suspicious. Yeah. It's like, are you really being honest with me? We've got to have at least an amber somewhere. And you're telling me there's no red issues? And it's like running just looking at your line reports as well. Yeah. And if there's no reds, everything's working perfectly, but we know the world doesn't work that way. So, failure is, I worked with James Dyson in my career. Yeah. I worked for Dyson, and there was one kind of mantra, unspoken mantra there, which is making a mistake is not a problem, yeah, because you learn from it. Making the same mistake twice starts becoming a problem, because actually you haven't learned, you haven't adapted to the situation. So the same applies to these sorts of projects. Getting it right all the time doesn't actually help, to be honest. Having some failures, sometimes by having a failure, a new opportunity emerges from it you didn't predict in the first place. You could start off trying to do predictive maintenance and actually find out that by using the energy data, you've found a massive hole in what you're doing. You're running the machines much too high a power, or they're running idle for way too long. You've found a new case, a new benefit, which is not necessarily what you started to have in the first place.
That's interesting. And I can relate it back to Senseye, actually, because I spoke to one of our delivery team a few months ago who told me a little story about a customer who was almost reluctant to provide negative feedback about the app, that it missed something, or I can't remember the exact details, but in fact he was sort of saying, no, you should be telling us this, because like I said, it almost creates, if you spin it positively, it creates an opportunity for something else, a new place to focus on, a new just new ways to improve. So it doesn't always have to, a negative that can be turned into a positive quite easily in those circumstances.
I work with a brilliant guy called Pete Morris, and a big shout out to Pete on this. But with Pete, I gave him some feedback recently. I said, look, sorry, mate, I've got this idea for you. Here's some feedback. Very well constructed. I used to think I did it. I think I did it constructively. And he went, no worries. Feedback is the food of champions. It's like great. None of us can get better if we don't get feedback on what's going on. And that applies to the projects you're running as well.
Yeah. Applies to every walk of life, actually. I'd probably broaden a bit out, speaking from personal experience. But no, that's fantastic. I think we're coming towards the end, and as regular listeners will know, we always, and you would know as a regular guest as well, we sort of try and end with, there's been a lot of practical sort of takeaways today anyway, but if there's sort of one or two things for people to sort of take away and start thinking about when thinking of running these AI projects, what would that be?
So I think all my advice is probably going to be centered around proving the impact. Because again, it's not that the technology does not work. It works, yeah? In fact, as I said earlier on, the capability of these technologies is outstripping our ability to use them and create value from them. And if you have that in the back of your mind all the time, don't ask, where can we use AI? That's the wrong question. Ask, what's one problem we must solve? What's the one critical problem? And then, could AI help us? So value comes from solving for impact, solving for an outcome. That gets everybody bought in. Other people, so convinced that AI can be used and adds value to them, because obviously everybody, I guess, will start from a misconception that AI is a risk to them as opposed to an opportunity. It solves the financial question and the CFO question that you need to answer. And you move from actually solving, or you solve a real problem and not showcasing innovation and technology. And make sure that that real problem is not a point and isolated thing. It's something that is replicatable across the facility. You've got 5 of the machines of the same type that occasionally have those issues, or you've got 3 other factories that have the same equipment. So start where the pain is, but make sure that that pain is felt in many places, because if you don't have that, then your pilot or your proof point, however valuable, is only ever going to be applicable there and will never scale, and the impact will never increase.
Absolutely. And scale is where the big success is, right? So that should be the aspiration, of course. But yeah, no, thank you so much, Nick. Really useful advice. We're going to, I think we usually do after your episodes, we'll link to your website and LinkedIn so people can connect with you afterwards if they want to discuss any of these topics further. I guess that covers everything from your side in terms of where people can learn about you.
Absolutely. I think LinkedIn is the most things, and then obviously On my website, we have the Beyond the Buzzwords blog, which we probably post once every 4 to 6 weeks, which generally covers some of these topics and some of these points we talked about today.
Excellent. So yeah, we'll link to those. But for today, thank you again, Nick, for joining us and sharing your expertise. And thank you everyone for listening to this episode, and we'll see you on the next one. Thank you very much.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.